Go. Okay, everybody, a little recap of what we did. We did 3 different problems out of our workbook today. The first problem is on page 310. So I'm on page 310, and I'm doing number 7b. So the question really is, if you have a polynomial that's been divided by x plus 3, and the answer is 3x squared plus 14x plus 15, with the remainder 3, to get back to the original polynomial, it's as easy as multiplying these two and adding the remainder. And I gave an example of if you had a number, some number, and it's divided by 5, and the answer is 4, remainder of 3, the way you get the original number is you multiply these two. There's 20 plus your remainder, 23. So we'll do the same thing. We just multiply the x plus 3 times my quotient, which is my 3x squared plus my 14x plus my 15. I just foiled it, that times that, 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 times that. All right, so I just did my FOIL, and I wound up simplifying it. And then finally, I also added my remainder of 3 in here, so I got my 45 plus my 3 makes my 48. So this was the original polynomial, divided by x plus 3. Its answer was 3x squared plus 14x plus 15 with remainder 3, okay? So I just multiplied the 2 and added in my remainder. We also looked at a problem on page 315. So I went through some just random problems I thought kids would need to know. So on page 314, I did number 5. So before I do a whole lot, if I look at this graph, I know that x minus 6 is a root. So if x is equal to negative 6, and that's a root, then I know the remainder is 0. So what I did is we said, okay, well, let's just do synthetic division. And so I used negative 6, and I divided my polynomial, knowing full well that I should get a remainder of 0. And I did. I did negative 6. My polynomial was 1x cubed, 11x squared, 37x plus 42. And I did my synthetic division. I brought down my first term, and I multiplied. I added, then I multiplied. Added, then I multiplied, and I got a remainder of 0. Okay, awesome, got a remainder of 0. This then is going to be a 1x squared, 1 less power, 1x squared plus a 5x plus 7. Now, I know for sure that this has got to have an imaginary answer. It has to, because it doesn't cross the x-axis. So I took my 1x squared plus 5x plus 7, and I used the quadratic formula, because it does not factor. In fact, these numbers I know won't be real because it doesn't cross the x-axis. So using my 1 for A, 5 for B, and 7 for C, I plugged them into my quadratic formula. Negative 5 plus minus 5 squared minus 4 times A times C all over 2 times A. I simplified my quadratic formula to negative 5 plus minus square root of positive 25 minus 28, 4 times 1 times 7, all over 2. And then I knew I'd get a negative, which I suspected imaginary anyway, square root of negative 3. And then I would have an answer knowing that I'm going to have an I right here, square root of negative. So I have a negative 5 plus my square root of 3, I over 2, and that represents my imaginaries right up here. I did one last problem for the kids. I did a problem on page 315. And on 315, again, I have this polynomial x cubed minus 9x squared plus ax. I don't know a. I want to find a. A is some number, x plus 60. But I know that x minus 5 is a factor. Well, if x minus 5 is a factor, then its root is x equals 5. Okay? So if I plug in 5 with some synthetic substitution, I have to get an answer of 0. So I plug it in, get an answer of 0. So I plugged in my 5, set it equals 0. Plugged in my 5 for x, plugged in my 5 for x, and I set it equals 0, because I know it has to equal 0. So then I just simplified 125, negative 225, 5a plus 60. I added my integers. I got negative 40. I solved for a, plus 40 divided by 5. A is 8. So this would be the polynomial. The value of a is 8, and it has a root of 5. And that's what I did for today, and I did give an assignment as well as some math. Okay, that's all I have.